Hello everyone, and welcome to some properties of exponents. Today we're going to talk about exponents and how they work. And there's the first part where we're just going to talk about some properties, and then we're going to see them in action down here. So don't forget that this is a video, and the best way to learn off of videos is that if you find I'm going too fast, you can always pause at one point and see if what I'm saying makes sense. And if not, you can rewind it a little bit and watch it again. Also, there are going to be points where I'll stop and I'll say, hey, why don't you pause the video and try this problem, see if you get it right. So I would suggest doing those things as well. But please take advantage of the fact that this is a video and that you can rewatch it or you can pause it. It'll be very helpful for you if you are starting to get confused. Okay, that said, let's go ahead and get into these properties. The first property is called the product of powers property. And what these are saying is letting A and B be real numbers or letters. They can also be variables, and M and N be integers. So those are things like -2, -1, 0, 1, 2, 3, 4. And what the product property means is, first of all, product means multiply. So if you have two separate bases, this is very important. If you have two separate bases that are the same base, then what you are allowed to do is take those exponents and add them together. And notice once again, it is the exact same base. The bases do not change. So if you have two different bases being multiplied, you can add the exponents. That is different than the next one called the power product, which power is, exponent. Notice this time, there is only one base. It is a to the m to the n. There is not another a being multiplied by. That is a big difference. And it's very important you can tell the difference. Because in this one, when there's two bases, you add them. But if there's only one base, what you're going to do instead is to multiply them. It's going to be m times n. So they get multiplied. And it's the same base as before. Power of a product. If you have an a times b to the m, this is the same thing as a to the m times b to the m. Since this whole thing is to a power, everything in it has to be put to a power. So a to the m and b to the m. It's kind of like distributing, but just keep in mind you can only distribute exponents if it's multiplication in here, only because it's multiplication. A negative exponent property. If you ever have a negative exponent, what this is going to do is it is going to change it into a fraction. So I'll write down fraction. Negative exponents make things into fractions. So instead of a to the negative m, this is the same thing as 1 over a to the positive m. So keep that in mind. The negative becomes positive. So the negative goes to positive. The only thing that changes is that it is a fraction. And keep in mind, it does work the other way as well. If I had a 1 over a to the negative m, so this time there's a negative exponent, but it's on the bottom of a fraction, it is going to flip to the top. So you'll have a to the m on top. And now there's nothing in the bottom, so it would just be that. So it's really a negative exponent is flipping its location in a fraction. Because this is technically over 1 right now. So if it is a fraction in the top with a negative exponent, it'll go to the bottom. If it's in the bottom, it's going to go to the top, kind of like that. And it can do some combination of both of them. If you had something like a to the negative 2 over b to the negative 3, then both of them are going to switch locations. This a squared, because it's negative, is going to end up on bottom, but positive. So the negative 2 becomes a positive 2, but it switches its location. And with b, it would be a b to the third up top. The negative 3 becomes a positive 3, but it switches its location from bottom to top. So that's how it works, negative exponents. They flip fractions. The zero product property says that if you have an exponent of 0, that is always going to be equal to 1. That's it, the number 1. So anything to the 0 is always going to be 1. It doesn't matter how complicated it is. I could write down x to the 3rd, y to the 7th, x negative 8, like that, to the 0 power. Anything to the 0 power is 1. And that's just the answer. Anything to the 0 power is 1. That works with numbers as well. If you see 7 to the 0 power, that is also 1. Anything to the 0 is 1. The quotient is division. So if you have two things being divided, and once again they have to be the same base, these are both base A, kind of like when it was multiplying you could add them. With dividing you can subtract them. So it would be a to the m minus n. And just like before, if you have these parentheses, this is the same thing as a to the m over b to the m. And that is all the properties that we're going to be talking about. Let's go ahead and put some of these into action. First of all, just okay. First example is x squared to the 3rd power. So in this one, there is only one x and it's being put to a power and a power. Because of that, we're going to multiply these numbers and get x to the 6th. In B, we have two different bases. They are both y. And that just means we're going to subtract these exponents. So y to the 5th minus 3, or just, 5 minus 3 is 2. So you get y squared is the final answer. And that's because it's division, you subtract the exponents. It's one of the properties up here, right? If it's division, you subtract the exponents. In C, because it is a negative, I know my answer is going to be a fraction. This is a negative 4. That means it's going to have to be flipped to a positive 4 in the bottom. So this is going to flip to a fraction. Since there's nothing up top, we're just going to put a 1, because there's always a 1 if there's nothing. So x to the 4th, but in bottom. X to the negative makes it a fraction. Okay. In this one, there's multiple things to do. First of all, notice that the bases are the same, but this time it's a number. But remember, when we get our answer, the base is supposed to be the same. In all of the properties we've done so far, it's been a letter like A or X, but if it's a number, it's no different. This is a division. Since it's division, what are you supposed to do with the exponents? And that is to subtract them. 6 to the 5th over 6 squared, 5 minus 2 is 3. So this is 6 to the 3rd, and it stays a 6. The base stays the same. And then that negative 1 is still there. From that, we have two exponents. It's a single base to an exponent. So what do you do when you have an exponent to an exponent? You multiply. So this would be 6 to the negative 3rd. And then lastly, what do you do when you have a negative exponent? That is to flip it into a fraction. So this will be 1 over 6 to the positive 3rd. Now, 6 to the 3rd is an actual number. You could do it. 6 to the 3rd, it's 216. So you could write this as 1 over 216. It just kind of depends on what the question's asking for. Both of them are correct, just depending on what the purpose of the question is. Okay. Here in E, we got Z3, Z4. These are separate bases, but they're the same base, so you can combine these by adding them. Two different bases being multiplied, you can add the exponents. So that's z to the 7th to the 1/2. And then a single base with these, that means we're going to multiply them. So you get z to the 7/2. And that's all we're doing with that right now. We are going to do a unit later where this is going to be the same thing as the square root of z to the 7th, but that is a separate unit we're going to be doing. So right now, just worry about that. For this one, I would go ahead, pause it, and try it. It's a little more complicated than the ones before, but it is still the same rules. So go ahead, pause it, see how far you can get. Okay, first thing, these are x's and y's. They are not the same letter. Because of that, you cannot combine these things. This is just going to be x6, y4. You can, however, take half of these things. You are going to be multiplying these. So you'd get x to the 3rd y squared, because half of 6 is 3 and half of 4 is 2. Same thing you can do here. This will be x to the -8 and y squared. So distribute those. After that, we'll combine our x's, x3 and x -8. They are the same base, which means we can add these exponents. x3 plus x -8 would be an x -5. And then a y squared and another y squared. So you can add those exponents. Y squared, another y squared is y to the 4th. Total of y to the 4th. And then in the last step, because you have a negative exponent, the y to the 4th is not negative, so you can just keep it where it is. But because x is to the -5th, it's going to drop down to the bottom for that final answer. There are multiple ways to do this. Like, you could deal with this negative exponent now and make it to the 8th on bottom, or you could deal with it there. There's lots of different ways you can do it, but no matter what, you would end up with the same answer over there. And this video looks like it's a bit over 12 minutes already. So what I'm going to do is I'm going to pause this and make a separate video just to do more practice. And I'll see you there.